Okay, welcome back. Today, now we will discuss how to plot uh, functions in Python. Okay, now this is the introduction to PyPlot. Now we will be using the library PyPlot now to plot functions like sine, cosine, or logarithmic functions, or hyperbolic function, and etc. Okay, now in for today's learning objective, at the end of the lecture, the students will be able to plot mathematical functions such as line, quadratic equation, cubic equation, quadric equation, sinusoidal equation, what you call this, and logarithmic equation, exponentials, and others. Okay, now, so to introduce to you how to plot using Python, this is the matplot library. Okay, this is a collection of functions that MATLAB make Matplotlib work like MATLAB. Now, if you know about MATLAB, MATLAB is used. No, MATLAB is also a programming language. No, that is easier compared to other language. This is MATLAB is also a high level programming language. No, okay. Now, in MATLAB, no, you can easily plot functions like sine, cosine using MATLAB programming. MATLAB programming and Python programming is somewhat similar, especially when plotting functions. Okay, now so each pyplot function makes some change to a figure. Now you can say you can create a figure, you can create a plotting area, and you can plot some lines in the plotting area, or you can decorate the plot with labels. We will also use that as we go along with our topic. All right, now let's go to the basic of plotting. So I have here points or ordered pairs. Now we are going to plot this in three different approach. So for our first problem, now plot the given points 0, 2, 1, 4, 3, 7, 4, 2, 5, negative 3, and 6, 0. So we will use um, our first method is using plot scatter. Okay. Now before we use the Python plot, now we are going to import the matplot library. So this is matplot library. So it's here. So this is import matplot library. Okay, as okay, PLT. So meaning to say, instead of using matplot library, now we will be using PLT. Okay. All right. Now, after importing this library, we can now create a list of all values of x. Say, for example, in the problem above, now we have 0, 2, 1, 4, 3, 7, 4, 2, 5, negative 3, 6, 0. In this case, now I will get all the values of x, like 0, 1, okay, we have 3, we have 4, we have 5, and we have 6. So these are the values of x, as well as now we are also going to create a list of all values of y. So we have 2, 4, 7, 2, negative 3, and 0. So these are the points now of x and y. Now, what I'm going to do here is to call on the plot scatter, okay, function, and we are going to plot x and versus y. So we are going to plot x versus y. This is how you plot functions, or how you plot points using plot scatter. So this is plot dot scatter. put the value of x and the values of y, and then call on plot show. So plot show shows the graph. No? So this is used to show the graph. So show plots. And for plot scatter, it will plot all the points. Now let's try. Okay, run the code. Okay, okay. This is how scatter plot scatter is operating. So in here you can see here the points no that are plotted no in your x and y axis. Okay, now since the axes have no label, now we can label that using plt dot, let's say x label. We will label the x axis. So in this case, let's just call the x axis as x axis. And we are also going to label y axis using plot plt dot y label and then y axis. This is how you label, okay, x and y axis. Okay, again, run the code. No, running the code will print not the label no, along x and y axis. Okay, plot y plt y label. Okay, y label. So y label again, run the code. So there you go. You can see here the plot no, or the labels of your graph. You can also create a title for your plot using plt title and name of the plot. So plot of points. Okay. So again, run the code. So you can see the title no, is displayed no, on top of your graph. You can also display no, the grid. Now we can put a grid no, on your plot by typing plot grid. Now take note, a plot show must always be the last item, the last code that you will write. Okay, run the code again, and you will see the label, the grid of the plot. So that's how you plot using scatter, plot scatter. All right, this is plot scatter. Okay, take note of X label and Y label. Labels your X and Y axis and also the title. Okay, label your title. All right, now that is how plot scatter is used. Now, I will copy this code, Control C, and then I will paste it here. Now, this time we will be using the line plot. So a while ago, we used scatter plot. So for the line plot, now I will change this to plot. So plot is actually line plotting. So meaning to say it will connect all the lines now shown, all points now. This will connect all points now. Okay, plot using, I will change the title, line plot. Okay, that's my title. Take note, no, the same problem, no, I used no in your code. All right. Instead of scatter, I just used plot xy. So run the code, and you will see that the points are connected. Now, if you are going to display the point, now you can add another argument here. So this, take note, this is your plt.plot. And if you hover your mouse here, now you can see here the documentation of plot. Okay, so you have there the arguments. Now I can insert another argument. Let's say I want to plot now using with dots, line with that. So you can just say comma, single quote, minus small letter O, then run the code. Now it will display the line and the points. Now that's how this argument works. All right. Now, if you are going to display now the line now using dash, okay, you can just use dash and dash. Now, this will become a broken line. Okay, so that's how it works. All right. Now, okay, I will change this to uh, minus O so that you can see here the line and the points. Okay. Now I will copy this again, and this time we will be using bar graph. Now I will insert the code here. Take note. Now a while ago I changed scatter to plot. This time I will change plot to bar. So bar now will plot the points using bar graph. So you are going to remove no, the other argument. So for bar, no, you will only need x and y, and you can also use uh, the width no, of the line. So you can label that as, let's say, I want the width equals to zero point 0.5, no, and then run the code. Now this is how it works. Now the width is 0 0.5. Now by default, this is zero point 0.8 by default. We'll change this to zero point 0.8. Now, this is how the plot or the width of the line is changed. Okay, width equals zero point 0.8. If you will use 1.0, no, that's fine. So that's how it works now. So bar plots the points now using bar graph. Okay, now for your exercise number 1, I want you to plot these points. Now 0, -3, 1, 4, 2, 8, 3, 4, 4, 0, and 5, 7 using 3 methods, the scatter plot, using the line plot, and using the bar graph. So you have to insert your code here. Take note, exercise number 1 is actually, it's just a practice on how you plot the points. Now, I want you to answer this now because I will be submitting this Google Colab notebook. Now, I will be posting this to your Canvas module. Okay, now after plotting the points, now it's time for us to plot the line. So we will be plotting line y equals mx plus b. So in this case, we are going to plot y equals 3x plus 2 from x equals 0 to x equals 10. Take note, you have here the limits of x, no, from x equals to 0 to x equals 10. Okay, now, before we start plotting, we need to import. Now, we need to import the matplot library. So it's here. Just click enter. And again, we are going to import another function, another library. This is numpy. Okay, let's hover it here. What is this numpy? Okay, so numpy as np. So numpy is used for arrays. So arrays. Now this is used for arrays when you are when we say array. No, in our first example, now we created this. No, this is a list. No, or what we call this also an array. Okay, so that's why we are using numpy now, because we will be using an array here. So numpy. All right, so try to search now the documentation of this numpy. Okay, okay, let's start by, okay, take note, declaring the value of x. After we have imported all the library, we will now declare the values of x. Now using numpy. So This is linspace. Linspace, no, will create an array starting from 0 up to 10. So by default, no, take note, by default, the number here is equals to 50. You can see here the number is equals to 50. That's the default value. So so if you want, now you can insert how many divisions do you want. Let's say I want 10 division. So you can do that. But no, if you have only two arguments here, the first argument will be the starting value. The second argument will be uh, the ending value. Okay. Okay, now we have the value of x from 0 up to 10. Okay, from 0 up to 10. Now, if you want to print, no, let's say I want to change this to 10, meaning to say it will create 10 points from 0 to 10. Okay, let's say 11. And I want to print. Now, let's say I will print the value of x. Okay, let's just print the value of x and let's see what is this numpy. Now you can see here, no, the value of x will be from 0 up to 10. It actually creates 11 points from 0 to 10. So this is 11. So if I'm going to make this 21. Now, there you go. You have here 21 points. That is 0, 0.5, 1, 1.5, 2. That's how it works. Now, by default, this is 50. Okay, but I'm not going to print the value of x. Now, I will be using x to plot the function. Okay, now we go to plot. This time, we will be using line plot because we will be plotting a line. So we are going to plot the value of x versus, take note, we are going to plot the value of x versus the equation here. So in this case, instead of writing y, no, I will write 3x plus 2. So this is my second argument. The first argument is the value of x. My second argument is the value of y. So the value of y is 3 times x plus 2. Okay, that's how you plot function. If you press run, no, press run, the plot function or the line will be plotted, no, from 0 up to 10. So that's how you use the plot function. Okay, now this is your plot function. And then let's just label the axis. Let's say I want to label the x-axis. So we can have PLT x label, okay? And then insert now the label here. So this is x. Now let's say I will label the x-axis as x, and I will label the y-axis as y. Let's say this is y, okay? And then I will also create a title. Okay, let's say, what's the title? This is plot of, okay? We will be using latex equation, plot of y equals 3x plus 2. This will create an equation. Okay, let's run again. Run the code. There you go. You have your x label, you have your y label, and the plot. So plot of y equals 3x plus 2. That's how you create your code, okay, in plotting the line. Now, in the plot function, I will insert another argument here. So this time, I will change the nature of the line to a broken line. And then I will change the color to, let's say, red. So this will become a broken line and red. Okay, run the code. Now you will see this is a red broken line. Now, if you want a dash dot line, so you can say dash dot, and then let's say this is blue. You can say blue. Run the code. So it becomes blue, dash dot, and then it becomes a color blue. That's how you manipulate now the nature of the line. Okay. All right. Now let's proceed with the other mm, function. So this time, I'm going to plot the quadratic function. So this is a quadratic function, y equals x squared. Now, we are going to plot y equals x squared, now starting from -5 up to +5. Now, before you plot the function, you are going to import the matplot library. Again, mat, okay, it's here. Plot library dot pyplot as plt, meaning to say instead of typing this long library, I will just use plt. Okay. All right. Now, since we are going to use linspace, we need to import. Okay. We need to import numpy, no, so that we can use linspace. So in this case, now I'm going to put the value of x as np dot linspace. Take note, this will create an array of the values of x starting from -5 up to +5. That's how linspace works. No? After putting the value, we now go to the next line to plot the function. The first argument is the value of your x. The second argument is your function. So in this case, I will be using x squared. So x squared as my function. Okay, now run the code. You will see here, the plot of the parabola. Okay, this is a parabola. When we say quadratic equation, it means parabola. Okay, we can label. We can put labels here. Let's say plt dot x label. So we can label the x-axis as, let's say, this is my time. Let's say this is time. And I'm going to label the y-axis, okay, as my time and then my value. So assuming now this is the label time and then value, and then again now I'm going to create a title, and then I will label the title as, okay, plot of, okay, y equals x squared. Okay, run. There you go. You have here plot of y equals x squared as your title, and you have here the y label as value and the x label as your time. And if you wish not to put grid on your plot, you can say plt grid. Okay, run the code again, and the grid will be automatically uh, printed as well. Okay. Now, if you want to plot another line, let's say I want to insert another line. So I want to plot another line. Let's say plot another line, not another line. I want to plot another parabola. Okay, this time now I'm going to plot x squared plus 4. Let's say we will also plot x squared plus 4. But now we are going to change the nature of the line here. In this case, I will be using dash, and I will color it red. And I will insert here another value, another argument, let's say color green. Okay. I will not change the line. No, I will make it a solid line. So let's plot. So here, now if you have to plot two or more function, no, you must change the nature of the line. Let's try. So this is the nature of the line, okay? And you can actually create labels, like for example, okay, label, no, okay, is equals to, this is the argument. I will label this as y equals x squared. So I will make this as a lattice equation by inserting, by enclosing y equals x squared by a dollar sign. Another label equals, so this is, okay, I will make this a lattice, y equals x squared plus 4. So, and then I will put a legend. Take note, this is very important. If you are plotting two or more functions, no, always put a legend. Okay, run the code. There you go. The red one no, is actually your y equals x squared, and the green curve is your y equals x squared plus 4. Okay, that's how you plot multiple functions. Now for your exercise number 2, I want you to plot the function here. I will add a code. I want you to plot the function y equals 2x squared minus 3x plus 4 from x equals negative 10 to positive 10. So this will be your exercise. Now you can plot multiple curves in one program. Now you can do that. Just invent another curve you want to plot. Okay. In our next example, we are going to uh, plot the square root function. Okay. In your calculus, this is very famous, especially when dealing with range and domain, the square root function. So we will plot the square root function starting from 0 to 10. So we will start by importing the library. Okay, matplot. So press enter. Okay, and then I'm going to import numpy. Okay, press enter. Okay, the first thing to do is to put the value of x. So we have numpy or np linspace starting from 0 up to positive 10. That is according to the problem. And if you want to plot the function directly, you can say plot, okay, the value of x, then square root. Take note of the square root. Take note, we are going to use numpy for the square root. So this is the syntax np square root. Okay, inside np square root, you have here the argument. So the argument will be x. Okay, that's plot plt dot plot. Okay, okay. Now let's try to plot this function. Run the code. Okay, here, there you go. This is the square root function. Okay, now if you are going to change the direction, now you can just say, I will make this negative so that it will change direction. Okay, but take note of this. Now, if you are going to do this, square root of negative values will create an error. So it will not print. Okay. Okay. If you want, now you can change the direction by multiplying negative 1. Multiply to that, and it will change the plot from the upper part going to the lower portion. Okay, now that's it for the square root function. Now, if you want to insert title, X label, Y label, you can do that. Okay. Now, for your exercise number 3, I want you to plot the function y equals 2 plus square root of x minus 1 and set your own limit. Take note, the value of the square root functions should always be greater than or equal to 0. Okay, so you should set your limit such that this will not become an imaginary. So what do you think is the limit here? What do you think is your domain? Okay, this is just a review of your calculus subject. So your limit will be actually your domain. Now we are going to go to our next function. We are going to plot y equals to e raised to x. Y equals e raised to x, starting from 0 to 5. Now let's start by importing MATLAB matplotlib function library. Okay, and then importing numpy, okay, as np. Okay, all right. Then putting the value of x, this will become np linspace, okay, np linspace, and then from 0 up to 5. This time we will be plotting e raised to x. So when you, if you want to plot e raised to x, you can use plt dot plot. No, your first argument is the values of x, and your second argument is your e raised to x. So in this case, since we are using numpy, this is numpy e raised to x, that is denoted as exp. So np exp is actually the argument is actually your x. So this is how you use the function or the numpy to represent the exponential function. All right, now let's try. Let's plot the function here. Okay, numpy. Now, so this is your np that exp x, or this is y equals to e raised to x. This is how you plot functions. So I will not be putting labels here or grid. No, we will proceed to another function. We call this one your logarithmic function. Okay, ln stands for your natural logarithm. This is the logarithm to the base e. Now, in your calculus, you can actually change this to log to the base e. Okay, now let's start now by plotting the function from 1 to 20. Take note, I use 1 because log of ln of 1 is 0. Okay, take note of that. Can I use 0 here? No, it will create an error. Like for example, ln of 0 is negative infinity, if you can still recall back in your calculus. So in this case, now I will import the matplotlib library as plt, and I will import numpy as np, and then I will put the value of my x. This is np linspace from 1 to 20, and I will plot the function using this plt dot plot my value of x, and then my ln. So in MATLAB, in Python, using numpy, so you can represent ln as np log of x. So log is actually natural logarithm. If you are going to change natural logarithm to logarithm to log to the base 10, you can change log to the base 10. This is the syntax for your log to the base 10. For natural logarithm, you remove 10. So this is log or natural logarithm. So press run. That's it. Now this is the plot of your natural logarithm. All right. Now we are going to plot multiple functions of sine and cosine. So in this case, we are going to plot functions y equals sine x and y equals cosine x from 0 to 4 pi. Okay, since we are now ready, now we are going to import matplotlib library as plt. And again, we are going to import numpy, okay, as np, because we will be using um, an array here. So in this case, now I will create an array of the value as a value of x. Now this is linspace. So in this case, I will use 0, okay, comma. Take note, we have 4 times. Since we are using numpy, we can say numpy pi. So this is actually 4 times pi. So pi can be represented in numpy as np dot pi. So that is the value of your x. All right, now we need to create a plot function. So we have here plot, no, the value of x. This time I will plot sine. So instead of sine, I will use np sine of x. Okay, and I will change the argument. Let's say I want to create a broken curve of sine of color red. And again, I will plot cosine x and p dot cosine as a function of x. I will change the argument as I will just change the color to green. Okay. Now run the code. Now you can see here that both sine and cosine is plotted in one axis. Now the red the red broken curve is actually your sine. You can create a label here if you want. Now just like we did in our previous example. You can create a label and later on you can put a legend. Okay. Okay, exercise number 4. I want you to plot 3 functions. Take note, you have to put correct labels and a legend for this exercise number 4. All right, now this will be our last topic for today. So the subplots. No? So in these subplots, we are going to create multiple function in each axis. Multiple plot, one for each axis. So we call this one plt.subplot. Okay, take note, plt.subplot, no, or plt.subplot is represented by this argument, let's say 211, okay, or you can have a comma or you may remove the comma. The first number is the number of rows, meaning to say subplot 211 will create 2 rows, 1 column. Take note, 2 rows and 1 column. And the last number here is the position. So meaning to say 2 rows, 1 column, position number 1. So this is 2 rows, 1 column, position number 1. Since this subplot and this subplot is just the same. Okay, now I'm going to create a subplot now using the functions here. So exp, this is actually e raised to minus x multiplied by sine 2 pi x. And for our second curve, we have y2 equals exp minus x multiplied to cosine of 2 pi x from x equals 0 to 5. Before we start our plotting, we are going to import a matplot library as plt. Also, we are going to import numpy. Okay, import numpy as np. Okay, all right. Since the values of x to both the functions is common, we can just say linspace. Now np dot linspace. Okay, and then from 0 to 5. That will be my values. Okay, now we are going to subplot two function. So to subplot the two function, you can say uh, plt dot subplot. Okay, let's say 211, meaning to say 211, 2 rows, 1 column, position number 1. In my first plot, no, I will plot the first function y1. So in this case, the first argument is the value of x. The second argument is np dot exp multiplied by exp and then negative x multiplied by, so take note, this is my first function. We are going to multiply that to np dot sine, okay, of 2 times, take note pi, we are using pi here under numpy, so we can say 2 times np dot pi multiplied by x. That's how to plot the first function. Let's try. Okay, this is just my first function. Now to plot the second function under subplot, you can say subplot. No, this time I will be using the first row, second row, two rows, one column, but this is in position number 2. Okay, so I'll just copy this one, okay, and then change this to sine. Change this to cosine. Okay, this is now my cosine. Press run, and then there you go. You have two functions. One is sine and one is cosine. You can actually create an x label here. Let's say plt x label. Okay. You can say time. Okay. Let's say let's just label the title. Okay. Plot of y1. Okay. You can create another title here. Plt dot title. Okay. Okay. Plot of y2. Okay, run. There you go. No, the title of the plot, we have plot of y1 and plot of y2. You can also change the nature of the line. You can say, I want this to be dash and dot, color red. Run the code. So there you go, dash and dot, color red, and my second plot. Now I want this to be um, asterisk. Let's just use asterisk here. Color blue. Okay, run the code. So there you go. This is an asterisk, and the other core will be a dash and dot. Okay, now that's it for today. Now I will post now your programming hands-on activity number 6 later on. No, it's not yet here. Now I am thinking of an activity that can do all of these topics that we have a while ago. Okay. Okay, I will see you next meeting, and study hard and study smart.